Okay, so my dear friends, we will be now solving this paper, May-June 2024, paper 6, variant 1. Time is 1 hour, as we know, marks are 40, and it is 20% of the weightage from our curve or examination point of view. Let's start from the beginning. Now, a student investigates the stretching of a spring. Student investigates the stretching of a spring. Figure 1.1 shows the apparatus. And then next is the student measures and record in table 1.1 the unstretched length LO, in other words the original length, and he does not include the loops at the ends of the spring in his measurements, so loops are not included. What do we mean by saying loops? Length is measured, if you ask me more technically, length measured is from this point to this point, like this. Okay, so the hooks are not included in the length of this measurements, whatever. Describe one technique you would use to obtain an accurate value for LO, mean original length. Draw a diagram to illustrate your answer. So you need diagram also to illustrate your answer. Now please, if any one of you wants to comment on this, welcome. Otherwise I will be starting the answer. For this one. Waiting for your response quickly, my dear friends. If any one of you is willing to answer it, feel free, you can ask me. Otherwise you can. I will be writing the answer. Waiting for your response, my dear friends. So one thing that you should use, the ruler. It should be very close to the spring. It should be vertical, and while measuring the length, you are supposed to avoid the parallax error by keeping the line of sight perpendicular to the scale. Line of sight what? Line of sight perpendicular to the scale. So this is the technique which you are supposed to follow. And now if you want that how to draw it, so I will be drawing it for you people just now. Okay, what do you think? What can be the other answer here? Complete silence. So I'm not drawing a separate diagram here for you people, dear students. I'm just making it here. So first of all, the ruler should be straight, and we can use a set square to keep the ruler vertically upright. What is a set square? In your geometry box, if you will open the geometry box, there will be two triangles like this. One on this side, the small one you can draw on the other side. That's not necessary that big one should be out or small one should be out, but no worries, like this. And you will show that there is no gap between the ruler and this. Now this is set square to make the ruler, or to, and then now we will be writing it in our own words. Okay, no problem. No, I will be sharing it inshallah at the end. No problem. Don't worry about this. So this is something which you will show, and then show your line of sight, line of sight at 90 degrees. So these things you have shown on the ruler, on the diagram figure 1.1. Now you can write the same things here. So now I'm writing, place the ruler close to the spring. No, yes, to the spring. Keep the ruler close to the spring and keep it vertical. Keep it vertical by set square method. That's what I told you what is set square method of. And then also write that the line of sight, because 2 marks are there, line of sight is up to the scale of the ruler, like this. So inshallah this will be giving you completely 2 marks. If there is anything, any confusion, feel free, you people can ask me. The student suspends a load L equal to 1.00 Newton from the spring. He records the new length L of the spring in table 1.1. He calculates the extension E of the spring using the equation E is equal to L minus LO. So L will be the stretched length under the influence of some load, and LO will be the unstretched length, original length, and records the values of E in the table 1.1. The student repeats the procedure using the load 2 Newton, 3 Newton, 4 Newton and 5 Newton. And also one thing more, sometimes you will be told, you will be asked, to write the values into the table. Like here, this side will be blank. This load times load per Newton column, load in Newton column will be empty. Only you will be given the values. Then you will be asked, sorry, to completely fill it up. So always remember, there should be a regular interval between the values. Either it is for independent variable. Independent variable here is load, because load is attached to the spring by the student or by the teacher while performing this experiment, and as a result of that load, this length is independent variable. So dependent variable, length is dependent variable which keep on changing, and ultimately the extension is also changing. So always go regular interval. See 0 then 1, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, 4 plus 1 5. A regular interval. It does not mean 0 then 1, next value 2.5, next value 3, then 5, then 7. We are not making any sense. So always regular intervals must be taken for the independent variable, in this case that is the load. Calculate the extension E of the spring using the equation E is equal to L minus LO when the load is 5 Newton. Record this value of E in table 1.1. Now load, length, and this E over centimeters. What is this? This is the LO. Why this is LO? Because no load is attached. This is the original length, unstretched length. Now for 5 Newton, this is L. How to get the values? L minus LO, it means 23.7 minus 2.1. So answer is, see, 23.7 minus 2.1. It is equal to, 23.7 minus 2.1. Answer is 21.6, and here I am going to write 21.6. That will give us 1 mark. Plot a graph of load in newtons on y-axis. Load in Newton on y-axis against extension E in centimeters on x-axis. When I follow this instruction, I have scored my first mark. Then start both the axes at the origin and draw the best fit line. Draw the best fit line. Now 0 0, and we need to use the values 0, 1, 2, 3, 4, 5. So already there is a lot of stuff available. So this is 1.0, this is 2.0, here 3.0, 4.0 and 5.0. More than half of the grid must be covered, and the extensions are from 0 to 20. What I can do 0, this is 5.0, this is 10, this is 15, here it is 20, and here it is 30. Sorry, why 30? This will be after 20, 25.0, 20.0, 15.0, 10.0, and see regular intervals. And I have scored the second mark also. The reason for that, because more than half of the grid, the data is covering more than half of the grid on both axes. Like there are 6 squares on x-axis, 5 are data is occupying 5 squares, and there are 6 squares, big squares on y-axis, and data is occupying again 5 squares. So more than half. So second mark is also scored. Now we need to locate the points 1, 2, 3, no problem. But what about this side? What is represented by one small square? I can take the difference in two consecutively marked values to save our time. So 5 minus 0 over 10. Why? Because 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So each box is equal to 0.5 centimeters. So 2 boxes equal to 1. Okay. So when the force is 1 Newton, extension is 3.9. Extension is 3.9. So 1 Newton and 3.9. See, this is 1. 2 boxes equal to 1. This is equal to 2. This is equal to 3. This is equal to 4. Just a little bit ahead of it. So this is the first square. Then at 2 it is 8.5. 2 Newton, 8.5. See, this is 10. This is 9. This is 8. So 8.5 is in the center. Then at 3 Newton, it is 12.8. 3 Newton, see, this is 10. This is 11. This is 12. This is 13. 12.8, little bit before this. So this is 12.8. Before 13. And then at 4 Newton it is 17.2. 4 Newton, this is 15. See, here it is 4 and from the bottom this is 15. So we need to get 17.2. So 15, this is 16, this is 17, almost here, same point, 17.2. And then, my dear friend, the last value is 5 and it is 21.6. See, 5 and 20, this is 21, this is 21.5, so almost here. Now, my dear friends, we have located all the points and we prefer to use crosses in IGCSE Physics paper to plot these points. If you will use dot, then it is recommended by the examiner that dot should be within a circle. Now, the final mark will be scored by plotting a line of best fit, and very important thing which you need to remember, that point this line of best fit will be there. The length of this line, it should be within, in such a way that either it's passing through all points, or if one point is up and the one is down, so that will be well judged. And for this purpose, it is recommended that you are using a transparent scale. And the thickness of that line is also very important. The thickness of this line should not be more than this line. These lines which are describing are differentiating the big squares. So don't use a thick line. Well judged thin line is needed to draw these lines. Well judged thin lines. Okay, my dear friends, now I'm trying my best to draw a line of best fit. Let's see, because it is on computer, so bit difficult screen, so you can judge it well and you can do it better than me what I'm going to do. Probably This is almost the line of best fit. It was supposed to be a little bit up, but it's okay. Just I have given you the concept, so you scored your 4th mark. So it means in the graph question, it is not the case that all the lines you will draw and then the graph marks will be given till the last line, but you know it has the marks of steps. So labeling, then occupying the more than half of the grid with the data, and then plotting the points, and then finally the plotting the graph line. So 4 marks. Next, it will be the gradient.
Mister, I have a question.
Yes, my dear.
Can you say again, how did you find the value of the 23.6?
Not 23 point. Here up
Oh
20.
yeah, 21.6.
Yeah, 21.6. No problem. Yeah, Rata, please. It is not possible in paper 6 that you have to find something, you have to write something either in the table, or you have to calculate by using formula, and it is not given. It is given. Now see, calculate the extension E of the spring using the equation E is equal to L minus LO when L is 5 Newton. So L is 5 Newton here. LO first of all is the case. LO stands for original length, unstretched length, and it is only when the load is 0. Spring is its original form. Now then rest all of them are L. Why? Because 1 Newton, 2 Newton, 3 Newton, 4, 5 load is attached, so the spring will keep on stretching. So that length of the spring under the influence of load will be stretched length. So he said particularly at 5, so 23.7, and this is L. So L minus LO, 23.7 minus 2.1, 7 minus 1, 6.3 minus 2, 1, and like this. So that's what I did, mean this value minus the original value. Please,
Okay.
Mariam, any question?
No, that's okay.
Okay, welcome, you know. Next is determine the gradient of the graph, show all your workings and indicate on the graph the values you use. The values you use. Remember always, whenever the examiner will say you in exam to get the gradient, you are supposed to draw a triangle. Triangle method seen. If you will open the mark scheme, no answer, but it will be written triangle method seen, and you have to use triangle very precisely, as large as possible triangle you can use, and show it clearly to the examiner by plotting like this dotted lines, and largest possible triangle. And then now see, this value is x2, this value is x1, this value is y1. What is y2? Roughly I am choosing this value as y2. So y2 5, y1 0. What is x2? This is 20, this is 21, and x2 is basically 21.5, because 1, 2, 3 boxes and each box is 0.5. So now we will write the formula here. G is equal to y2 minus y1 over x2 minus x1. y2, it was 5, minus y1 0, x2 21.5, x1 0. So 5 divided by 21.6. Sorry. 5 divided by 21 point, it was 21.3 maybe. Yes, 21.5. Okay, fine. It means I was right. So answer is 0.2325. So we will write 0.23. Now 0.232, and then in the answer you can write 0.23. There is no need of writing the unit over here, but they never asked, by the way, till not write the unit of gradient. But if they are asking, no problem, we have a brain. Gradient is rise over run. This is Newton. per centimeters. Newton per centimeter. So we can write here Newton per centimeter, but not needed. Remember it till it is not asked. G is numerically equal to the spring constant. Okay, record the value of K to a suitable number of significant figures for this experiment. Include the unit. So now 0.23 include the unit. Rise over run. Rise is Newton, run is in centimeters, so Newton per centimeters. This was based on Hooke's law. Now let's move to the next question. That is an electricity question. A student investigates the resistance of a wire. Figure shows the circuit used. The student measures the current I in the circuit and she places the sliding contact. You know, this can keep on moving. Sliding contact S at a distance D is equal to 50 centimeter from B. She measures the potential difference at V50 at 50 centimeter, which we call as V50. Length D of the resistance wire. Figure shows the ammeter and voltmeter readings. Ammeter reading. Now you people are going to tell me what is the ammeter reading. 0.2, this is 0.3, then yes, please write the value of this ammeter reading. Tell me. See, this is 0.2, here this is 0.3. If you go for the least count or one small division, what it is representing, so 0.2 divided by 10 minus 0, when you can write because marks like this, so it will be 0.02. so this is 0.2, then 1 2 3 4 5, this is 0.3, then 0.32, 0.34 and 0.36. No, oh my goodness, only Muhammad Gamal answered it correctly. So it is 0.36, and don't forget to write amperes. So similarly, the values for potential difference, it will be 1.4 and volts. Why? Because here least count is 1 minus 0 divided by 5. So each line is representing 0.2 volts. So resolution of this voltmeter is 0.2 volt, while the resolution of this ammeter is 0.02 amperes. So 1.4 volt and 2 marks are scored. Please, if anybody having a confusion or doubt, feel free, you can ask me. Now calculate the resistance R50, a 50 centimeter of the resistance wire, using the equation R50 is equal to V50 over I. V50 is 1.4 volts and I is 0.36 amperes. Unit will be ohms. So answer is 1.4 divided by 0.36, 3.88. So what I'm going to do, I'm writing 3.90 ohms. Basically, this is 3.88. Now, calculate R1, a value for the resistance per centimeter of the resistance wire using the equation. You know, see, they are so nice. Equation is given. R1, R50 over D. R50 is 3.89. I will use over 50 because D is equal to 50. So answer this one divided by 50. 0.0777, so we can write 0.078. 0.0777, so it means 0.078. But what will be the unit? Very important. This is in ohms and this is in centimeters, so ohm per centimeter. They said include the unit. The student repeats the procedure in A using D is equal to 75. Calculated R2 using this formula. Now all the values are there. So 2.2, R75 is 6.1 and then R2 is 0.081. Student suggests that the resistance per centimeter, mean R1, R2 of the resistance wire is constant. State whether your results Support this suggestion and justify your statement by reference to the results. No problem, we can do. It looks to me yes, but wait, but wait. What to do, my dear friends? You will not show to the examiner this thing. This you will do for yourself, and in some other experiments I shared the two values you have for R. 2 0.08, R1 0.078. So calculate percentage error, or you can write uncertainty. What is the method? 2 times the difference of the values in numerator, sum of the values in denominator times 100%. Please pick up your calculators now. Difference in the values. So 0.078 over 0.081 minus plus 0.078 times 100. Please tell me how much percentage is this. Pick up your calculators and do it. Write it in the chat box quickly. Okay, dear friends, so you gave the answer to be 1.88, 3.78. Why these different answers? What is this? What is this? How come different answers for different people? Two people said at 3 point, yeah, 4 people. So answer is 3.78, 3.78, 3.89. So it means I'm just using your information. So I'm writing here 3.78%. Now, my dear friends, listen, you will follow this method. Whenever two quantities are given and there is a difference in the two values and they are saying it should be constant, means it should stay same. And then statement and justification. Statement, always you are writing either yes or no, except some condition is there that increases, decreases, stays the same. Then you will choose increases or decreases or stays the same accordingly. If nothing, no key is there, then you are simply writing yes or no in the statement and calculate the percentage error, and the rule for that is 2 times the difference in the two values in numerator over the sum of the two values in the denominator times 100%. It should be better that I'm writing here 100% also. Anyhow, so 3.78%. Now, if your answer is less than 10%, write here yes, and you will give the justification that within the limit of experimental accuracy. Why so? Now check, this is percentage error. What is the accuracy of your experiment? 100 minus 3.78, 96.22. So your experiment is 96.22% accurate. High ratio of, or high percentage of accuracy. So if your percentage error comes within 10% or less than 10%, in statement we are always writing yes, and we are saying within the limit of experimental accuracy. But if this percentage error was going to be 30.7%, we were going to write in the statement no, outside, you are beyond the limit of experimental accuracy. Outside or beyond the limit of experimental accuracy. And when to write this? When your percentage error by using this rule, it is more than 10%. And luckily sometime, by chance sometime our answer is 0.081 and their answer is also 0.081, then simply you will write in the statement yes, don't write limit of experimental accuracy, then you will simply say they are both equal, like this. Please now comment on this if you have any doubt or question. And this all is shared with you people already. These points in case of keynotes for paper 6. So he's saying the student plans to plot a graph of the resistance R against the D to test the investigation, suggest additional values for the length. You know, he used 50 then 75. What we are going to do? 60 centimeters. You write the values. 70 centimeter, 80 centimeters, 90 centimeters. Four values are these. Means 0 to 100 centimeter, any value you can write in a sequence, but go with a sequence. So 50 is already having, then 60, 70, 75 he did already, 80, 90, like these values are enough to plot a graph. A variable resistor is in a circuit component. Variable resistor is a circuit component that can be made using a coil of a resistance wire. Draw the electrical symbol for a variable resistor. Very common, very common. This is the symbol of a fixed resistor. Just place an arrow. It will be a variable resistor. It will be a variable resistor. Now, my dear friends, let's move to the next question, which is going to be, yes, lenses. A student investigates the image produced by a lens. See, this is the lens. Here is the screen where the image is made, by the way. Image is made on screen. Illuminated object, and then here is the illuminated object. Here is the object whose image we are seeing, and lamp is there to illuminate it, to make it brighter. On figure 3.1, then figure 3.2 shows the height HO of the illuminated object. Now always remember, sometimes they are saying, okay, draw the diagram for this. So lens is always in between, screen is on extreme right, and with a block to support it, to keep it vertical. This is a block to support it or to keep it vertical, and there will be illuminated object, and a lamp will be shown before the object. Like here, lamp is there. This lamp is making the object illuminated object, and here is the object already they mentioned. On figure 3.2 shows the height HO of the illuminated object. See, I'm using the values which are in front of me, and by the way, these are not the correct values. These will not be the correct values. The reason, because this screen is bit zoomed in, but in actual exam you will measure from where to where, from this arrowhead to the other arrowhead, and arrowheads are included. I'm trying, but it will not be, of course, the accurate answer. For me it is giving 1.8 here now. Yes, 1.8. So I'm writing here, and this is basically more than maybe marks key value also. So 1.8 centimeters. Figure 3.1 is drawn to scale. The actual distance U between the illuminated object and the lens is 20 centimeter. On figure, measure the distance X. On the figure, measure the distance X. We have to measure this distance X. And centimeters, how much is this? Again, I'm going to measure it. And believe me, for me it is coming 2.2. For me it is coming how much? 2.2. Because these values are not going to be correct, but practice. Okay, from where I measured? From here till here. For me it is 2.2 in centimeters. Calculate the scale ratio R using the equation where U is equal to 20 U over X. U over X. Okay, U is 20 and X is 2.2. So 20 divided by 2.2, 9.09. So I will write 9.1. We can write 9.1, and no need to write centimeters, because centimeter is cancelled with centimeters here. Cancelled. Follow the instructions, nothing special. By the way, this stuff I am seeing first time, but not difficult. The student moves the screen until well-focused image is formed on the screen. On figure, measure the distance y. So I will measure the distance y now, which is from this point till this point. And your values, if you have printed this paper, may be different than me. For me, it is almost 7. Almost what? 7 centimeters. So I am writing it 7.0 centimeters. Calculate the actual distance V between the lens and the screen by using equation V is equal to Ry. V is equal to, what was R? 9.1 times 7. Where is R? Just we calculated here R, which was 9.09, so I rounded off to 9.1. So my dear friends, it is 9.09 times 7, 63.6. So 63.6 centimeters. Now calculate the focal length of the lens using the equation UV. What was U? U was 20, I think. Yes, U is 20. V we just calculated. So 20 times 63.6 over 20 plus 63.6.
Mister, it's 63.7.
Really? For you or for okay, you know what is the problem? Don't worry about this, because here it is written 9.1, but in my calculator actually it was 9.09. Are you with me?
Yeah, I did 9.1 times.
Yeah, you did 9.1. You can write your answer, no problem. That's not a problem. Don't worry. Okay, now calculate and give me the final answer here. Yes, dear friends, what is the answer? 15.2. Asil, good year of that. Thank you. Stay blessed. 15.2, but don't forget to write centimeters. Give your answer to suitable number of seconds. Yes, same. 15.2 centimeters we can use. Okay, Mariam, Asil, your answer is matching. So 2 or 3 significant figures workable, because see here 3, here 2. So 2 or 3. So we will go with 3, no problem. Now, in this type of experiment, it will be difficult to judge the screen position, and that produces the correct, clearest image. Precautions are techniques to overcome this difficulty. You know, in this type of experiments, no. Perform the experiment. Perform the experiment in dark room or shaded area to judge the screen position well. Secondly, very common point, just go and read. Move the screen slowly back and forth to get clearest image. This is the clearest image. Quickly I will share these 2 points. Like if you are in a seminar, in a workshop, where you are sitting in the theater and the speaker is on the stage. So the lights of the lights of the theater are off. Only on the stage there are dim lights, and a very strong light is there on the speaker, the professor, the actor, the politician, and very focused. Everybody is focused on that image. Or even in a cinema hall when the on, movie is being played, darkness or throughout the hall, only the screen is brightest. So that is the concept, that is perform the experiment in the dark room when you are using the light illuminated object and its image is formed on the screen. Second thing, move the screen slowly back and forth to get the clearest image. Clear image is on a very small point. I can tell you, if you are in front of the photographer, so they are not directly taking the image. If you ask me, dear students, what is he doing while you are sitting standing in front of the cameraman and camera is on the stand like this, so he is moving the lens something like this very slowly forward and backward, and where he finds that the image is clear, clicks and flash is on and the image is made. So these are the techniques, and many I have shared already with you people on the in those paper 6 keyboard. There are 5 written or 6 ways are written. Anyhow, figure 3.2 shows the shape of illuminated object. The image of the object is enlarged. Draw a diagram to show the image that you would see on the screen. See, the two types of images are there. Real image, which can be formed on the screen. Virtual image, which cannot be formed on the screen. It means this image is formed on the screen. Figure 3.2. This is the image. So same, this is the object basically. Same you have to show, because it is real image. A real image is inverted, but it is enlarged also, something like this. That is enough. 1 mark. So be very concentrating in the exam and observe. Go back to figure 3.2 and it is formed on the screen. It means it is a real image, and real image is always inverted, upside down. Okay. Oh. The student investigates the bending of composite strips. Composite means 2, 3, 4 wooden types of wood are joined together that are loaded at one end. Here, like in the diagram, this is the composite wood, and in between some adhesive liquid or fluid is there, and this side is clamped with the table with the bench with a G clamp. This is known as not only clamp, technically this is known as G clamp. See, its shape is like small g. See, G clamp. And other side here we will attach the loads. This will bend and we will be measuring the bend by height or by the angle. The composite strips are made from identical layers of wood stuck together. Okay, identical layers of the wood stuck together as shown in figure. Plan an experiment to investigate how the composite strips bend when they are loaded. Load now are the weight. This is independent variable. Independent variable. This will be changed by Muhammad Tariq while performing the experiment. And this bending, this will be dependent variable. The student has number of composite strips made with 2 or more layers of wood. Diagram in front of you. State the variable that you are testing. It can be height, it can be angle. List any additional apparatus. Height, we need a ruler. Angle, we need a protractor, and also we need loads. Loads are not mentioned there in the apparatus. Okay. How you will investigate? Variables to keep constant. So of course, length of the wooden strips, even the diameter, table, and then explain how you will reach to the conclusion. So one by one, we will be addressing all the points. Now, my dear, I will be writing that meter rule is needed measure the bend when strips of wood are loaded. This is the first one, just a little bit. Otherwise, you can write meter rule and test your list any additional operator. Okay, state the variable that you would use. Oh, sorry, variable I was supposed to write. Okay, I have written it already into this point. Okay, now next here say additional operators I wrote to measure the bend with strips of wood. These first 2 points are mentioned here in this line. Now next is very method to do it. So what I'm going to do, next point I'm going to write that add a load to the free end of wooden strip and measure the amount of bending. And then always in this one you can say repeat the same method by using or by adding, not using, better to say by adding different loads to the wooden strips. So this is the method you can say followed. Then key variable to be kept constant. Length of the wooden strip must be kept constant. And you should write the answer in paragraph. Length of the wooden strips is kept constant. Then of course next is table. So in table you can draw the table independent variable in the first column and bending in centimeter you can write, or change in height from the ground that you can write, no problem. And we are not supposed to write any of the values over there. So how to reach a conclusion? Next one will be, see, no need to write, you are not required to write any. Explain how you will use your readings to reach a conclusion. So my dear friends, plot a graph of bending on y-axis against load on x-axis, and then always write this point that repeat the experiment. In the end you can add this to get at least 5 sets of data so that easily you can plot the graph. So this is paper 6.1. One more paper I have discussed with you right now. And if you have anything to ask, please feel free. You people can ask me.